But then, of course, for so many other domains where privacy and efficiency matter, we start to see a lot of use cases like time series foundation models, financial signals, and really spanning and going further beyond, pushing the frontier, redefining what it means to be a foundation model from first principles.
Hello, I'm Matthias. I'm co-founder and CTO of Liquid AI, and I'm sitting here with my co-founder and friend Alexander.
Yes. Thank you, Matthias. I'm co-founder and chief science officer, Alexander Amini. Thanks for having me.
So we're training foundation models at Liquid AI, and one training paradigm that's very hot at the moment is reinforcement learning. And for a large language model, it means like working in text space. But I think, or we think as a company, that there are much more interesting modalities.
At Liquid, we believe that we build massively multimodal foundation models, right? This spans far beyond text, even far beyond human interpretable modalities like image and audio. We care a lot about biological signals, drug discovery, and how we can build foundation models for those domains. But the fascinating thing about those domains is, as you mentioned, the learning signals are so different, right? There's very sparse learning signals because the learning signals are oftentimes only validated when you actually generate the molecule, generate the protein. So oftentimes we need to become very clever in how we design learning algorithms to learn over those spaces. With language models, we have this hallucination problem, but if your language model is generating biological sequences, drugs, we definitely want to minimize the hallucinations as much as possible. And especially for a small model, that's a huge problem, right? So you need this very tight calibration.
There's a recent paper that was published by Liquid and our partner Insilico Medicine about this. Can you elaborate a bit?
So Insilico Medicine is this really a frontier drug discovery company, and we recently partnered with them to create a new biological foundation model using our LFM2 base. And we actually trained this LFM2 base using a lot of their wet lab data and their biological data more broadly. These are multi-billion parameter models. They can speak over the language of biology, but also reason over the language of language, natural language as well. And we want to directly be able to synthesize these in the wet lab. We've already identified actually several key targets of different biological domains and functional families that we want to actually bring our technology into the wet lab for. We view this as like one of the most powerful instantiations of physical intelligence in some ways, right? The language of the physical world is biology. It's biology, chemistry, and so on.
And what other modalities are we considering beyond biology?
Audio, vision, which present very interesting design choices, technical design choices, because these are oftentimes very continuous modalities compared to text, which is much more discrete. But then, of course, for so many other domains where privacy and efficiency matter, we start to see a lot of use cases like time series foundation models, financial signals, and really spanning and going further beyond, pushing the frontier, redefining what it means to be a foundation model from first principles.
And we at Liquid design specifically foundation models also for devices. So typically means like very small or very efficient. Does this make your job easier or more difficult?
Rather than easier or difficult, I think each domain actually has different challenges and benefits. For example, if you think of images, right? Images are extremely rich pieces of a modality to be able to encode these into sequences. And if you need to distill all of this into a very small backbone, a very small foundation model, this is a lot of compression that has to come, right? So in this way, it's a very difficult problem to optimize for because it's a very deep compression problem, even much more than language in some sense. But then you have other domains where actually you leverage this efficiency to your benefit for this modality. And biology is one of these examples that actually being more efficient is directly beneficial to those models because we have biological sequences like DNA, for example, that are the context length of our own human genome is billions, right? So if you just literally want to prompt with human genomes, this is not possible with the language models unless they are massively efficient.